These are your 8-1A notes, the simplifying rational expressions. This is our introductory to the rational functions chapter. And a rational expression is a quotient, so it's a fraction of two polynomials. So if you remember number sets, a rational number is a fraction in simplest terms. So we're going to have fractions that have exponents, or I'm sorry, variables as the numerators and denominators. They can be very simple. It could just be one variable over a number, or the other way around, or it could be a trinomial over another trinomial. So they can be very complex as well. So just know the whole idea of a rational number is a fraction, and so these are rational expressions. They're fractions with variables in them. And that's pretty much what I just said there. So a lot of the properties of what we're going to use in this chapter mimic the properties of regular fractions. So in this first simplifying day, we're going to mimic how you simplify a numeric fraction, and then we're going to apply that same concept to these rational expressions. An undefined value is when you have a value of the variable that makes the denominator equal to 0. We've done some undefined values, for instance, when we did square roots. When we worked with square roots, okay, when we had the square root of x, we had to say that x has to be greater than 0. Because if not, then it's negative, and you can't have negative square roots. So it's kind of, you put a limitation on some things. So for instance, in my example up above here, with this 3x, the value of the variable that makes this equal 0 would be 0. If I plugged a 0 in for x, multiplied it by 3, I'd get 0 in the denominator. So I would simply just say x cannot equal 0. I'm telling you the undefined terms. It doesn't exist. There's no number there because you can't divide by 0. Whereas this other example, there are no undefined terms because you can divide by 5. And if I plug 0 into that second equation, it would just mean 0 divided by 5, and that's okay because that's actually equal to 0. So we just look their values. We're going to start looking at that a little bit. It's important when we go to graph these things and when we solve. So when we simplify fractions, I'm going to take it down to the very basics of simplifying. We simplify these things so quickly now that we don't really understand the basis behind it or why we get to do these things. So in number 1, I know that I can take I have a 12 and I have 45. I can take a 3 out of each of those. So what we've learned to do is we divide by 3, and simplify. But the basis behind dividing by 3 is really you're eliminating a common factor. So if I look at 12 in factored form, in its true factored form, it's 2 times 2 times 3. Okay, 12 is 4 times 3, but then 4 can factor down to 2 times 2. So 2 times 2 times 3 is 12. And when I look at 45 in its factored form, it's 3 times 3 times 5, which is 9 times 5, but I just even broke down 9. And now you can see that if you divide by 3, you're basically eliminating the common factor. So here's a common factor 3. It's common because it's in the top and the bottom. So if you simplify that and say a 3 divided by 3 cancels itself out, it is in fact like dividing by 3. So the top gets 3 times smaller, and the bottom gets 3 times smaller, or a third of the size. And so we'd end up with 4/15. And that's the simplified form of 12/45. If you look at number 2 here, right, so we factor 24. Now, if you can't factor 24 in your head, you can always make a little factor tree. Okay, so we go 4 and 6, and then 2 and 2, and then 2 and 3. So the factored form of 24 is 2 times 2 times 2 times 3. And for 30, it would be 3 times 10, which is 3 times 2 times 5, because 10 is 2 times 5. And so when you look at this, the common factor between 24 and 30 is 6. You knew that. You really didn't have to break it down. But I'm breaking things down because I need you to see it when we have not-so-friendly fractions. And so what's left is 4 and over the 5, so 4/5. If I just was to divide this by 6, divide this by 6, I get the 4/5. Number 3, we actually saw earlier in the year, this is a monomial. So The only way we can factor these things is to really break down that a cubed. So we could call 10 2 times 5, and we could call a cubed AAA, if like expand it. And then write down the b. 5 times 5, AB. So monomials really don't follow the rules of factoring like other binomials and trinomials. Cross off the common factors. And so what I'm left with is a 2a squared over 5. So they do like to sprinkle a few of those into this lesson as well because there's unknowns and variables and that sort of thing. So when we actually go to simplify rational expressions, we're going to use that same logic that I just demonstrated above. We're going to factor the numerator and denominator. Okay, now how you factor is a little bit different than I did the factoring of numbers. It may be difference of perfect squares. It may be a trinomial. We have to look at maybe a greatest common factor. So you might want to review your factoring notes. And then you just cancel the like terms. So let's go ahead and look at these couple problems here. Number one is somewhat factored for us. It's not all the way factored. You can't break down a 3, you can't break down a y, and y plus 7 is its own factor. So when there's parentheses around it, you can't break that down any further unless you were going to break it into more parentheses or take out a GCF. So that one's finished. Y plus 7 is in the bottom, and I just want to, again, emphasize that when it's in parentheses like that, it's not a y value, it's not a 7, it's y plus 7. It's a number that whatever you plug in for y, you add 7 to. The second quantity in the denominator can be broken down again. I notice it's a difference of perfect squares. So actually, I can break this one into y plus 3 times y minus 3. It really didn't help me in this case because I can't cross them off, but I needed to look. So I can see that my common factors that I can cancel are the y plus 7s. I cannot cross off any of those 3's because one's a 3 and the other one's a y plus 3 or a y minus 3. I can't cross off this y in the numerator because these other y's in the denominator are not y's. One's a value of y when you add 3 to it, and one's the value of y after you subtract 3 from it. So the remaining factors are the 3y on the top, and on the bottom we have that y plus 3 and that y minus 3. Now, you could just leave it in that form. Some people prefer to distribute that and clean it up, and so you'd get back to that y squared minus 9. I really don't care which way it is written. Looking at number 2 here, to factor the top, I can see that they both have an a and a b in them, so that's my greatest common factor. So I'm going to factor out an ab. It doesn't go away, it just goes on the outside, and that leaves me with a quantity b minus 5. On the bottom, I have a 5 plus b, and I have a 5 minus b. Looks really close like I could cross something off. Those b minus 5s and 5 minus b's look like I could cross something off. I can't do anything with this ab, so that's going to remain. The 5 plus b is the same thing as b plus 5, so that can't go anywhere. But these other two quantities are so close. But the problem is, one of them, they're actually opposites of each other. They're not the same factor. It would be like a 3 and a negative 3. So there'll be a remaining negative 1 somewhere. So what we can do is we can switch one of them. I'm going to factor out a negative 1 from the top. By taking out a negative 1 from that quantity, that would make my positive b turn into a negative b. And if I factor a negative 1 out of negative 5, it turns into a positive 5. Now I have a positive 5 here and a positive 5 in the bottom, a negative b and a negative b. So these two quantities are the same factor. But notice I do have a negative 1 that I took out. So my final answer will be negative ab on top over 5 plus b on the bottom. Notice when I took out my negative 1, I only took it out of one of the two quantities. I could have easily taken it out of the bottom one, but anytime we have negatives, we like to put them up top anyway. So you could call that negative ab or negative 1ab all over 5 plus b. Now I didn't mention it, and I don't know if the homework, I can't remember if the homework does it here or not, but let's talk about excluded values. When we talk about excluded values, they're the values of x that don't work in the original problem. So if I look at all of these factors in the original problem, It's so much easier to find excluded values when things are in factored form. And you have to name excluded values prior to simplifying. So the excluded values in number 1, x is not allowed to be -7, and y, I'm sorry, that wasn't an x, that's a y. Y cannot equal -7, -3, or +3. There's actually 3 excluded values for number 1. If I plug in -7, this quantity here will turn into 0 in the denominator. If I plug in -3, that quantity will turn into 0, and the whole denominator will turn into 0 because you're multiplying by 0. And if I plug in 3, that one turns into a 0, which makes the whole denominator turn into 0. So my excluded values for number 1 would be those 3 values. Like I said, I don't know if they make you do this in the homework tonight. We'll look at that, but I want to get just thinking that way. So in number 2, the excluded values for B, I'm looking at these 2 quantities. What value of B makes that first quantity equal 0? -5. And what quantity of B makes the second one equal to 0? +5. So we simply state B is not allowed to be -5 or +5 because that'll give us 0 in the denominator, and that's undefined. All right, a couple more problems, a little bit more involved factoring. Okay, what I do not want to see is you crossing off these x squareds. That is not acceptable, okay? Common mistake. So what I'd like you to see is maybe put parentheses around them so that you understand that's not an x squared, that is not a 5x, and that is not a 6. That is the quantity, x squared plus 5x plus 6. It is one whole number that when you plug in a value for x, you square it, you add 5 times it, and you add 6, it's a number. And the bottom is not an x squared or a -4. It's the combination of x squared minus 4. So we're going to factor. You factor first. Factor, factor, factor. The top is a trinomial, and I'm just pretty good at factoring. I know that what did we multiply to get that? X plus 2, x plus 3. I'm looking for 2 numbers that multiply to give me 6 and adds to give me 5. 2 and 3. The bottom of the difference of perfect squares. It's been a while since we factored. One's positive, one's negative. That's why the middle term went away. X plus 2, x minus 2. Now we have common factors. Now this x plus 2 is the same number as this x plus 2. Okay, whenever you plug in an x value and add 2 to it, it'll be the same on the top and the bottom. The other 2 quantities, though, this number adds 3 to x. This one subtracts 2. They are not the same number. So we're done with x plus 3 over x minus 2. Now, if you looked at the excluded values, x cannot equal positive or -2 because those 2 values cannot be 0. X is allowed to be -3. That's in the numerator, and numerators are allowed to be 0. Okay, number 4. So for number 4, I notice that I have an a in both of these, and actually I have 4 of them. So I'm going to factor out an a to the 4th. And that leaves me with b minus 2. That was just a GCF. And on the bottom, I noticed that there are 2 a cubes. So I'm going to take out an a cubed, and I'm left with 2 minus b. Well, there's that same issue of -1. So I'm going to quickly factor out a -1 on the top. That makes my b negative, my 2 positive. Now these 2 quantities match. And now what I have is a -a to the 4th. Over a positive a cubed. And if you actually expand that, that's a monomial. I really have a -1 times a times a times a times a over a. And so 3 of those a's are going to cancel. All that's left is a -1 times a. My solution is -a. Now you didn't have to expand that. If you could just see that I have 4 a's on top and I have 3 on the bottom, I'd have a -a left over. That's fine. Excluded value, if you look at this, there's 2 different excluded values. A cannot equal 0, because in the denominator, if a is equal to 0, that would be incorrect. And here, b cannot equal 2, because when you plug in a 2, that quantity would equal 0. So notice, every time I do excluded values, I'm always working with the factored form before I cross things off. It would be really difficult to come up with 2 and -2 out of the non-factored form. It's really difficult to see that when they're not factored. So we factor, figure out the excluded values, and then simplify. All right, so your lesson summary, I want you to determine just the undefined terms of that expression, so you need to factor. And really, they only deal with the denominator, so good practice. Factor the denominator and then figure out what the undefined terms are. And then I want you to simplify that rational expression, so you will eventually have to factor the numerator as well. Good luck.